numbers. The first one is called a commutative property. So we have a commutative property. And this property works for both addition and multiplication. So when we have two numbers, let's say number A and number B, this property tells us that we can add them together in any order. So we can first take the number A and then add B, or we can take the B number first and then add the number A to it. So this is very obvious, but yeah, it's one of the properties. And it doesn't work only for addition, but also for multiplication. So we can also multiply these numbers A and B in any order we want. So A times B equals B times A, and that's pretty much the commutative property. One of the basic properties in mathematics. And the second property which I would like to talk about is the associative property. Associative property. Alright, so this time we will have three numbers instead of A and B. We will have also a number called C right here. Let's add the plus sign here and here. So this time we are adding three numbers. Let me write that to the right side as well. We have A, B, and C. Plus signs right here. What this property says is that we can first add A and B together and then add C, or we can first add the B and C together and then add A. So these brackets tell us what we do first. So after adding A and B, we get a number, and then we can add these two numbers together, just like in the commutative property. We can add C first, and then A plus B, or A plus B first, and then C. So obviously this also works for multiplication. We have plus. Oh, sorry, that's not plus. We're talking about multiplication here. A times b. We can multiply numbers a and b first, and then multiply them by c. Or we multiply numbers b and c first. So we calculate b times c first, and then multiply the result by a. That will give us the same answer every single time. So since this chapter is called natural numbers, we will take that the numbers a, b, and c are a part of the natural numbers. So I'm just adding some new notation here. This sign right here means that a, b, c are the element of the set of the natural numbers. So the element of natural numbers a, b, and c. I did talk about the natural numbers in the previous video as well, where I explained which numbers are a part of the set of the natural numbers. I can maybe explain that again here. So these are the set of the natural numbers. Contains numbers 1, 2, 3, and so on. So these are the numbers we use to count things. Notice that 0 is not the element of the natural numbers, but it is 0 is an element of whole numbers. So if we add a little 0 to the set of the natural numbers, that just implies that the 0 is a part of this set, and that set is called the set of whole numbers. While these are just the natural numbers. So I did explain that in the previous video as well, but the previous video ended up very long. It's better to mention these things 2 times than not at all. That's pretty much all the theory we need here for the 2 exercises I prepared. And let's just move to the first exercise. First exercise is called multiply. As skillfully as possible. Okay, let's take a look at the first problem here. We have 2 times 38 times 5, and we need to calculate that as skillfully as possible. Now, what does this problem mean by skillfully? Now, skillfully means as fast as possible in my eyes. So we want to solve this as fast as we can, or maybe as in the easiest way. So obviously we could start by multiplying we still have to multiply 76 by 5. And that gives us, that gives us 380. So that is the result here, but yeah, it took quite some time. And additionally, these multiplications were not that simple at all. So what we can do instead is we use the commutative and associative properties. In this case, we will use the associative property. So remember, we instead of multiplying 2 and 38 first, we can actually multiply, let's say, 2 and 5 first. We know that 2 and 5 multiplied is 10. So that gives us 10 times 38, and multiplying by 10 in general is very simple. We just add an extra 0 to 38, that gives us 380. And so that was very, very much simpler. Okay, let's move to the next example. We have 14 times 25 and times 4. Now, we in the previous example saw that in general multiplying by numbers 10, 100, 1000 is very simple. We just add the amount of zeros right here to our other number. So in this case we added 1 0. If we multiply by 100, we add 2 zeros. In this case we add 3 zeros, and so on. So these are like the easiest multiplications, and that's why we kind of want to see that in our next example. So we could again multiply 14 by 25 first, and then multiply that by 4. But as we can see right here, 25 times 4 is 100. So we used the associative property again by multiplying these two numbers here first. That gave us 100, and then we can just add 2 zeros to number 14. That gives us 1100 as the result. Next problem. We have 5 times 20 times 27. So again, to solve this as skillfully as possible, again we see that 5 times 20 is 100 times 27. And that means we just need to add 2 zeros to the number 27. And that's our result here, 2700. Yeah, these problems are very, very fast. It's just to get the idea of maybe, just generally solving problems as skillfully as possible, as it was stated in the description above. So example D, this one will be longer. So you have to do 200 times 55 times 5 times 100. Okay, so what do we have here? We have 4 numbers here. last in this case. So again, we have a 100 here. That will not be a problem at the end. We will just need to add 2 zeros. And then we have number 5 and number 200. And by multiplying these two, that gives us 1000. So we can add, multiply 5 and 200, that gives us 1000. And then 55 and 100 remain. And now that means that we need to add a total of 5 zeros to 55. So that's 5,500,000. Since we multiplied 55 by 100, that's 2 extra zeros. And then 3 extra zeros from the number 1000. I will just underline the answers to make it a little bit more clear. Next example, example E. We have 8 times 37 times 125 times 2. So once again, we want to get a number that is either 10, 100 or 1000. That's a multiple of 10. And looking at these numbers, if we multiply 8 and 125 first, that gives us 1000. So we have 1000 times 37 times 2. And now we can multiply 37 by 2. And that gives us 74. Times 1000, which is 74,000. Alright, the final example of this exercise, example F. We have 125 times 5 times 2 times 2 times 7 times 2 again. So we have 6 numbers here. Okay, so yeah, once again we are trying to get a multiple of 10 somewhere. Alright. We know that if we multiply 5 and 2, we get 10. So just write the 10 here, and then 2, 7 and 2 remain. Now we know that if we multiply 125 here by 2, that will give us 250, and then multiplying it by 2 again, that will give us 500. We could alternatively multiply 2 and 2 first, that gives us 400. is also 500. So 500 times 10 times 7. I did 2 steps in one step here. Alright, so what is that? We know that 500 is 5 times 100. I'll just write that clearer. Times 10 times 7. This thing up. So we know that 5 times 7 is 35. And then at the end we just need to add a total of 3 zeros to number 35 since we multiply by 100, and then that's 3 extra zeros. And that is the final answer of this exercise. So obviously these calculations, these results we got were very, very nice results. They all ended with 0. But yeah, that was the point of this exercise. Not every calculation will be like that, but yeah, this one was nice to just maybe get that ability to notice when we can do things skillfully or fast without needing to maybe complicate things. That's generally a very good thing to look for whenever we solve problems. Alright, let's move on to our second exercise. And this one just says calculate. So we need to calculate this. Maybe, I don't know, maybe as skillfully as possible again. But no, that will not be the case here. The first example. So each example here will have 4 sub-examples. I will first write it down. These expressions. Okay, so we have 5 times 4 plus 3. The next one being 5 times 4 plus 3 in the brackets. Then we have 5 plus 4 times 3. And finally, we have 5 plus 4 times 3. 5 times 4 being brackets. So the idea here is just recognizing the order of operations. So I have seen a bunch of videos on YouTube where there is like a little quiz. For example, 2 plus 4 times 2. And a lot of people actually get this wrong, surprisingly. Most of people just go from left to right, add 2 plus 4 together, and then they simplify that to 6 times 2, which gives them 12. But that is wrong. That is not correct. What we need to do is multiply first. So multiply first, and then add these 2 numbers together, and that is the correct answer. So that is called the order of operations. So generally first thing we do is solve the brackets. So these brackets, if there are no brackets, or once we solve them, we do the multiplication slash division. These two operations are on the equal level. And finally, what we do is do the addition slash subtraction. So that's the order of how we jump into the problem, into equation. Just generally an exercise like this. Okay, so maybe I will leave that here for a bit. So this problem has the same numbers. The only difference is where the plus signs are and where the multiplication sign is and the brackets. So in the first example, we can go just from left to right. Since there are no brackets here, we need to do the multiplication first. So we need to do that step first. And then what remains is the addition. So that's 23. Now in the second case, we need to do the brackets first. So we need to add 4 and 3 together. That gives us 7. That's under the brackets. So, but we don't need to write the brackets here anymore. So now we do the multiplication. That gives us 35. Third case, we don't have brackets again, so we must do the multiplication first. 4 times 3 is 12. And now the addition, 5 plus 12 is 17. And the final case, we do the brackets first. We add 5 and 4 together, which is 20. Sorry, we are not multiplying, we are adding. That's 9 times 3. Now the multiplication. We get the 27, and we get 4 different answers here. Remember, if right here we didn't have brackets, if there were no brackets here, we would need to do the multiplication first, just like in the previous case. So that's why brackets are quite important in exercises. So the writer of this problem tells us what to do first. Alright, example B. Very similar, although this time we will have 3, let's say, parts to add together. Okay, that's the first case. The second case, we will have some brackets. Times 2 plus 5. So, some extra brackets. brackets on the other side. And finally, we will have double brackets. So that's plus right here. Okay, so in the first case, we don't have brackets, so we need to do the multiplication first. 7 times 2 is 14. Sorry, there is a plus here. Plus 5. And now we can just add them together in any order we want, really. Since we already talked about properties, commutative and associative properties before. 3 plus 14 is 17, plus 5 is 22. Okay, second case, we need to do the brackets first. So we get 10 here, times 2 plus 5. Now, next thing, we need to do the multiplication. We get 20 here, plus 5. And then we just add these two numbers together, that gives us 25. Third case, once again, the brackets come first. 2 plus 5 is 7. And now we are left with 3 plus 7 times 7. And we need to do multiplication here. First, 7 times 7 is 49. And now we just add these two numbers together. That gives us 52. And finally, we have two brackets here. So we just do these two brackets separately. First bracket 3 plus 7, that's 10. And the second bracket 2 plus 5, which is 7. And then we can just multiply these two. That gives us 70. And that's the final example here. Yeah. I do have one more example C under this exercise. So I have 1 plus 2 times 3 plus 4 times 5. And now we will add some brackets here. And then maybe add some brackets down there. And once again, I will have double brackets. So 2 brackets. Okay. Let's solve this. So in the first case, we can do the multiplication first. Now this is made of 3 parts. That's the first part, that's the second part, and that's the third part. The parts are often separated by the plus or minus sign. So in this example, this one has 2 parts. And there we have 3 parts again. Sorry, it's just one part at the end. So let's start here. We need to do the multiplication first since we don't have any brackets. So we can just write down one row before, and then in the second part here, 2 times 3 is 6, and in the third part we have one more multiplication, 4 times 5, which is 20. Let me move down this bar. And now we just need to add 3 numbers together, and that gives us 27. Alright, second case, we do the brackets first. We get 3 times 3 plus 4 times 5. Now this is made up of 2 parts. We can do these 2 parts. Now, since we are multiplying, we need to do the multiplication first. We get 9 plus 20, and that gives us 29. Third case, once again we do the brackets. We get 2 times 7 times 5. And we need to do the multiplication first in this case. So we have 2 times 7 times 5. Remember, in the previous exercise, we tried to skillfully multiply expressions. Vectors. So, by multiplying 2 and 5, that gives us 10. And that means we just need to write an extra 0 to the number 7. 2 times 7 times 5 is 70. And then we just add these two together to get 71. So, maybe I can write it like this. So, that's 2 times 10, and that's 70. But yeah. Final case, we have 2 brackets. The first bracket, the second bracket, and the third bracket. Yep. Alright, we just need to multiply 3 numbers here. Unfortunately, this time we can't get a multiple of 10. But these 2 numbers in general are not difficult to multiply. Okay, let's multiply 3 and 7 first. That gives us 21. And 21 times 5. Now that should be 105, I believe. Anyways, we know that 21 times 5 is the same as 21 times 10 times 1/2, right? Since if we multiply this part first, that gives us 5. Now that's how I created a 10 in my head. So 210 times 1/2. No, that's the same as 210 divided by 2. And if you remember the column division in the previous video, we take the 2, divide it by 2. 0 remains 1. 0, 5. So 105 and 0 remains. Oh, that was just a demonstration of what I did in my cat just here when we had to multiply numbers that didn't have a result, which was a multiple of 10. So, yeah. We can technically write 5 as 10 times 1 half, or 10 divided by 2. And that gives us a 10, but then we need to divide the result by 2. Alright. Maybe I will do one more exercise since I still have some time. This is the third exercise. This will be the final one though. It says calculate 8 ways. And then it also says figure out which one is easier. Yeah. Okay, so let's take a look at the first example. 3 times 34 plus 66. So there is another property which I haven't talked about yet, and it's called a distributive property. And distributive property, and that's kind of a combination of multiplication and addition. If we have a number a multiplied by the sum of numbers b and c, the result will be equal to a times b plus a times c. So as we can see, when obviously, oops, sorry, I deleted everything, didn't want to do that. Let me find the page. Okay, here we go. So when we have a multiplication, addition, and the brackets, right? We would kind of need to do the brackets first, and then multiply, and then get the result. But we can also simplify this to this in this way. So when we have something multiplied by b plus c in the brackets, we can just add this a to b and multiply a to c. So that's how this property works. And now, of course, we can use this property here. That gives us 3 times 34, sorry. us 3 times 66. But yeah, these are quite difficult calculations to be made. So yeah, 34 times 3, which is 102. And 66 times 3, which is 198. And once we add these two together, we get 300. But yeah, this way was quite difficult. It was not too hard, but it definitely took a lot of time. So alternately, we can, of course, we can just ignore this property and do the brackets first. And the brackets give us 100. And we just add 2 zeros to 3. We get the same result, since that's how the distributive property works. But maybe in other cases the distributive property will be actually easier. That's why it is important to know it. So maybe right, that's one way of solving, and that's the second way. And this one is definitely easier. Alright, let's move to the next example. Oh, we have a lot of examples here. I will try to be faster. Maybe save to talk for later. Okay, we have 997 plus 3 times 5. Now, okay, of course we can do the brackets first. We get 1000 here times 5, and that gives us 5000. Okay, that was really fast. I bet that's the easiest way. So let's start. That's the first way to solve this. Now, remember the commutative property. I explained it in the beginning. So we can actually use that commutative property right here. We have one number multiplied by another number, and we can just change the order of this. So we can technically write b plus c first, and then times a, and that gives us b times a plus c times a. And by the way, when we are using letters to kind of represent numbers, we can just ignore the multiplication sign. So yeah, in the previous video I was using the x as the multiplication sign, but now I'm just using the dot. However, when we have letters that represent numbers, we can just ignore this dot sign. It's very clear that this is representing multiplication. see. Of course, since the commutative property, since we know how the commutative property works, we can also change the order of these two letters right there, and we can write this just like the way we wrote this above, so like the result is the same obviously. So I'll just maybe write the equal sign right there. Yep. Now, why did I explain that? We have we can use the distributive property here as well, but in this case, right here, we have the number that's, we have the bracket first, while in the previous example we had a bracket on the last, as the last number, right here. So let's just solve this using the distribution rule times 5. So we multiply 997 times 5 plus 3 times 5. Okay. Now let's see. 997 times 5. Remember, we can add an extra 0 to 997 and then divide that by 2. But let's just calculate using the column multiplication. I explained how to do column operations in the previous video, so if you're not following that, you're welcome to watch that video. 5 times 9, 45. 48. Again. 49. That's the answer. We need to do the multiplication first, right here. Then the addition. So that's 4, 9, 8. Oops, that's actually 8, 5. Plus, okay, 3 times 5 is just 15. And then we just need to add these two together, and of course we get the same answer, 5,000. 5,000. And yeah, 4985 is exactly 1/2 times 9970. Since we can take this part as 997 times 10 times 1/2. So, oops. So the alternative approach to calculate this multiplication right here would be to write just another 0. Sorry. 970 and then divide that by 2, and we can use the column division now. So 4, 1, 9, 9, 1, 7, 8, 1, 0, 5. Nice. Or you can just do that in your head if you're fast enough. Whatever is easier to you. Each person has its way of solving problems. I'm just presenting some different ideas here. We are not the same. Everyone has its comfort zone So once again, the first way here was easier. It was shorter, and I mean, we can just clearly see that this gives us a multiple. This number right here gives us a multiple of 10. Alright, let's move on to the next example. We have 8 times 13 plus 8 times 7. Is that right? Yes. Okay. Now, the first approach to this problem would probably be to multiply this part and this part first and then add these numbers together. Of course, we need to do the multiplication first. So we have 13 times 8. That's 104. And then 8 times 7, which is 56. After adding these two together, we get 160. However, of course, once again, we can use this distributive property right here. But this time we do not have that left side of the equation. We have the right side of it. We have a number multiplied by some number b, and then once again the same number multiplied by number c. We have it right here, right? That's the same number multiplied by two different numbers. What we can do is we can write, sorry, there's a plus. We can write this using the distributive property. 8 times 13 plus 7, since that's how the distributive property works. And now we can do the brackets. That gives us 20, and 8 times 20 is 160. Depends, no, it depends which way is easier. Personally, the second way was easier for me, but I would say they're kind of on an equal difficulty level. But in the second way, you just kind of need to notice the distributive property. But for personally, this one was easier for me. I mean, we needed to do kind of more of a difficult multiplication here, while the multiplication here was quite simpler. Alright, next example. We have 278 plus 122 times 23. Okay, let's just do the brackets first. 278 plus 122, that's 400 times 23. Now we can write 400 as 4 times 100 times 23. And then we can multiply 4 us 92. And number 100 remains from the previous step. And then we just add 2 zeros to 92. So we did the brackets first, then we could technically multiply this already, like, but by kind of dissecting 400 into 4 and 100, multiplying 4 and 23 was kind of easier to me, since we just needed to add 2 zeros later. And we know that working with multiples of 10 is very simple. So that's one way of solving this. But yeah, once again we can use the distributive property to solve this. So 278 times 23 plus 122 times 23. Now this already looks harder, doesn't it? We need to multiply these two expressions right here. So the first one, 278 times 23, we need to do the column multiplication here. There's just no other way. So 2 times 2, 4, 5 plus 3 times 8 is 24. 3 times 7, 21, 23. 3 times 2, 6, 8. Then we add these together. And we get 6,394. That's from this part. Okay. Now for the second part, we have 122 by 23. 2 times 2 is 4, 2 times 2 is 4, then we have 2 here. And then we have 3 times 2, 6, 6, 3. Now we add these together, and we get 2,806. Okay. And after adding these two together, we can do maybe the column addition, just to make sure it adds up to 9,200. 2806. So 4 plus 6 is 10. 9 plus 1 is 10. 9 plus 3 is 12. And 1 plus 2 plus 6 is 9. And it really adds up to 9,200. And of course we get the same result as before. And yeah, this was definitely easier. That's the first way, and that's the second way of solving this case. This problem, yep. We have, let's see. We do have 5 more problems here. You can obviously skip some or solve them by yourself if you think you've already mastered this part. But I kind of want to solve all the problems here. plus 20 plus 1 times 30. Okay, so the first way is like the brackets first. So this in the brackets equals to 121. And then we need to multiply that by 13 times 13. So we get 1, 2, 1 plus 3, 6, 3. Adding these two together gives us 1,573. That's one way. The other way is using a distributive property, but this time we have 3 numbers in brackets instead of 2. But that's really not really a problem. You can still use the distributive property. It doesn't matter how many numbers we have in this bracket. So that's 100 times 13 plus 20 times 13 plus 1 times 13. Okay. Now we need to do the multiplication. In this expression, we need to do the multiplications first. In the first multiplication, we just add 2 zeros. In the second one, this is basically 2 times 10 times 13. Since 20 is 2 times 10, that means we can we can multiply 13 2 times and then add a 0. So that's 26 and an extra 0. And then plus 13. And then we just add these numbers together. That gives us 1,300. 1,560. 1,573. Again, we get the same result. We just used a different approach. Now, which one was easier for you? We needed to do a difficult multiplication here, while right here the multiplications were simpler, but we needed to do 3 of them. And then the addition here was kind of tricky. I kind of liked the second way better. It was, but maybe the first way is faster. And the second way was maybe more fun. So now which one was easier is up to you. Alright, next example. Example F, we have 9 times 2 plus 9 times 3 plus 9 times 15. Okay. Let's just write a line right here to separate these two problems. So the first way is just doing these multiplications. So we need to do 3 multiplications. We have 9 times 2, 18, plus 9 times 3, which is 27, plus 9 times 15, which is 120. this as 15 times 10 minus 1, and then use the distribution rule here. And we get the same thing, same result. So we wrote number 9 in the form of 10 minus 1. We wrote that under the brackets, and we use the distribution here. There are like just another way of solving this multiplication. The first way was column multiplication, and this is using the distribution rule. I think this one is easier to do in your head. Column multiplication is harder to do in your head without writing down things. So after adding these three numbers together, we have 18 plus 27, which should be 45, plus 135. It's 180. Okay. Let's delete this. This was just for our help. So that's one way. The second way is again by using the distribution rule. We see that the numbers here are multiplied by 9 each time, so we can kind of write that in a different form. So we have 9 times 2 plus 3 plus 15. And now we can do the bracket first. The bracket gives us 20, and 9 times 20 is 180. This is just like maybe an extra step to notice or to do the multiplication here easier or faster. But yeah, this part here is not really needed. Neither is this one. 180. We multiply 9 by 2 and then add an extra 0, since we have a 20 here. And personally, the second part here the second way was easier. We just noticed that each number here is multiplied by 9. We wrote it out of the bracket, and then in the bracket we wrote the numbers which were multiplied by 9, separated by the plus signs, since we have a plus here. And then we have a simple multiplication. Great. Let's see. We have the G example now. The G example. And we have 2 plus 4 plus 6 plus 8 times 23. Okay. Let's do the bracket first. 2 plus 4 plus 6 plus 8. We have 4 plus 6, which is 10, and 2 plus 8, which is also 10. Adding the tens together so it gives us 20 times 23. And now again, we can write that as 2 times 10 times 23. We can multiply 2 by 23, that gives us 46. extra 0 to the 46. That's the answer here. Now, let's use the distribution rule here. We have 4 different numbers added together in the bracket here. But the distribution rule still works. Doesn't matter how many numbers we have in the bracket. We have 2 times 23 plus 4 times 23 plus 6 times 23 plus 8 times 23. Now we can multiply each part. We have 4 parts for multiplications to the right here. Or we can just add these together. What do I mean by that? We have 2 23s, we have 4 23s, 6 23s, and 8 23s here. So we can just add 2, 4, 6, and 8 together, and then we get again 20 times 23. See, so we can imagine, instead of a 23, we have like an apple here. So 2 apples, plus 4 apples, plus 6 apples, plus 8 apples gives us 20 apples. Now, if we chose that method, if we just continue in a way we continued here, that would give us 460. But okay, let's just do the multiplications just to practice. We already did this, used this method in the previous way. So 2 times 23 is 46. Then we have 4 times 23, which is, I believe, 92. 6 times 23 is 138. And 8 times 23 is 24. 184. And now we need to add these together. Let's do column addition. 184 plus 138 plus 92 plus 46. So 2 plus 8. 2 plus 8 and 6 plus 4. That's 20. Then we have 70, 20, 26. And 2 plus 1 plus 1 is 1, so 460. We got the same result, obviously. We must get the same result. Yep. Once again, that was way easier. That took a lot of time. The second way was way longer. But we did get an idea to continue this from from here to here. But that just gives us still an extra step which we did not have in the previous way, which resolved quite fast. That was quite fast here. Okay, next example H. Let's see, we have 199 times 15. Okay, plus 15. Okay. times 9 here, 5, 8, 9, 2. So we have 2985 plus 15. After doing the column multiplication, and that the sum of these two terms is equals to 3000. That's one way. The second way, we can also write this as using the distributive property. We can see this 15 on the right side is equal to, we can write that as 1 times 15. Yep. And now we have two different numbers multiplied by number 15, and we can use the distribution here. 199 plus 1 times 15. Now after doing the brackets, we get 200 times 15, which we can write as 2 times 100 times 15. Now we know that 2 times 15 is 30. And we add 2 extra zeros to 30. That gives us the answer, number 3000. Now again, I would say the second part was much more fun. And the first part, this one was just shorter. I believe it took about the same amount of time that the second part, since we needed to do this multiplication here, which took quite some time. But yeah, using the distribution rule here, we got a very simple expression under the bracket that gave us 200, and multiplying 200 by 15, which was much easier than multiplying 199 by 15. Again, what basically says here is we have 199 number 15s, and then one more number 15, so that the total is 200 number 15s. Instead of number 15, we could imagine apples. So we have 199 apples plus an extra apple. That's 200 apples. That's pretty much what the distribution rule is all about. Let's move on to the final. That's the final example. Okay, so we have one more. I have 200 times 4 plus 50 times 4 plus 7 times 4. Okay, let's use the distribution rule first. So we have 200 apples plus 50 apples plus 7 apples. In this case, the apples are number 4s. So, using the distribution rule, 200 plus 50 plus 7 4s. That's using the distribution rule. We can do the bracket. Now, we must do the brackets first, right? So, the bracket gives us 257 times 4. Now we can use the using the distribution here. That gives us 250 times 4 plus 7 times 4. And we know that 250 times 4 is 1000. And 7 times 4 is 28. So we have 1028 as the result here. But yeah, I just rewrote this number in that way. And then I used the distribution rule to calculate the result much easier and faster. But yeah, we could also do the column multiplication. It would go like this, right? It's the same result. Okay. The second way is obviously just multiplying each part. We have 3 parts here. So that's 2. It's 3 parts separated by the plus sign. We have 200 times 4, which is just 2 times 100 times 4. Then we have 5 times 10 times 4. And then we have 7 times 4. So 2 times 4 is 8. And then 2 more zeros. Plus 4 times 5 is 20. And 1 more zero from the 10. And 7 times 4 is 28. And after adding these 3 numbers together, we get 1028 again. So we must get the same number, and so the distribution works anyways. So yeah. Which way did you like better here? I personally believe these are of equal difficulty here. Maybe in the first way, this one, we just needed to kind of notice the distribution. But I did like this one better. The first one, they are kind of an equal difficulty here. But yeah, that was the final example. Thank you so much for watching today's video. I hope you learned something new. Obviously, these topics are not too difficult. But if you've just started learning mathematics, maybe it will bring some interest to study even more. So, thank you so much. Thank you for staying with me till the end. And I hope I'll see you guys next time.